In previous classes, you looked at the concepts of exponential and log functions, and this serves as a brief overview of those concepts. First thing I want to make sure you remember is how logs and exponential functions relate. This equation is an exponential form with a base of a, and notice when we convert it to log form, these have the same meaning, just written differently. I like to remember that it's a base a raised to the power of x equals y. The same occurs with the special number e. When we take a natural log, we assume the base is e, and again, in this case, e is raised to the x power, which is equal to y. But let's remember what these graphs look like. I've already calculated the values here. Notice in this case, the base is 3, and in this case, the base is 1/3. It's important to note here that the base is greater than 1, and here that the base is between 0 and 1. In this case, the function exhibits growth as x increases, and in this case, the function exhibits decay. If I graph these two functions using these values, you're going to see that the intercept always passes through 0, 1, and in this case, the graph is growing. And with the graph to the right, it still passes through 0, 1, but the graph is decreasing. Notice it reaches an asymptote, a horizontal asymptote of the x-axis, but do also notice that both cases, these graphs are concave up, which will come important later in what we are studying. One of the biggest places that exponentials are used is within interest problems. Just want to make sure you know the pieces of these interest problems. In this case, this is the amount that we're trying to find after a certain amount of time t. P is the principal value or the amount that we're putting in. R is the interest rate, and it must be expressed in decimal form. N is the number of compounding periods within a year. So if it compounds monthly, that would be 12. If it compounds daily, it would be 365. N is the same value here, and then T is the years of which the interest is accruing. This is when the amount is occurring over a certain amount of time. Here, this is when we are compounding it continuously. But the other values remain the same. And I believe I spelled principal wrong there. My apologies for that. The last thing I want to point out here is the concept of log properties, and then we're going to use these to calculate or change the expressions here. These log properties, hopefully you can recognize, relate directly to the concept of exponents. When we multiply two things, the sum of the logs. When we divide, we subtract. The exponent creates a power that we can bring out front. If two logs are equal, then their values are equal. Notice here, if we convert this in terms of the base e to the 0 power is equal to 1. And these other two here, the ln of e is equal to 1, again, because e to the first is going to equal e, and our ln of x is equal to x. So how do we use these? Well, notice here, if I want to convert this to ln of x plus ln of y to one expression, I can use this fourth log rule here, or I'm sorry, the third log rule here, to rewrite this as ln of x squared plus ln of y. And then I can, because these are being added, I can then write this as one log being the ln of x squared y. Likewise here with division, I can simply combine these into x minus 4 over 2 using that second rule. Our third example here, we're going in the reverse direction. So notice I can separate this into ln of 5x minus ln of y. But then because this is a product, I can further separate it into ln of 5 plus ln of x minus ln of y. And last but not least, this one, it doesn't appear we can do anything. Notice we can't distribute this log across here, but I can factor this expression into the ln of x plus 5, x plus 1, which gives me the ln of x squared plus 6x plus 5. And now because I have a product, I can rewrite this as ln of x plus 5 plus the ln of x plus 1. And the reason we make these translations is because sometimes it becomes helpful when we're solving logs and exponential equations to be able to translate into one log or simply be able to convert into this form.